Okay. Hi, everyone. So first, thanks for the invite to Milice and to Milena. This was awesome. And then second, thanks to Damian and to Mile for the presentations. Absolutely inspiring, amazing stuff. I connect to these things a lot. And you guys are setting the bar too high. And because I'm stupid, I want to talk about two things today. So I prepared two demos. Let's see if can I get the timer? It's gonna be a little bit of a race, just so it becomes a little bit more exciting. Okay, so it is connected to what Mile was just describing. Basically, I'm making this platform called Cairos.ai. So our goal is that we give creative people more instruments. I am gonna talk a little bit, maybe all the way at the end, why we want to do this. Let's see first something cool, and then there is a philosophical thing which hooks up to the panel afterwards. So the goal is that we create human motion by talking to an avatar. I'm going to talk about how it works because I don't like usually talks that are kind of a show-offy. It's nice when you learn something when you're going out of the thing. So I want to give you some of the insights, even superficially. So that's me a little bit. So yeah, like was mentioned, if you have seen Iron Man with the house falling in the water way back in the golden era, this was me. So then I started my own company called Bottleship in 2013. We do a lot of simulation work, but also some characters and some environments when we can manage, and I still do some stuff. Like I was here in I think what was it, like, I don't know, it feels like 10 years ago when there was a Houdini masterclass, and then I switched, and it was a big romantic thing for me. I discovered a lot of creative outlet there and made me quite happy. So I have great fond memories. And there's a couple of projects that I am now fronting. One of them is Cairos.ai, and I'm going to try to make it to the next one also. So how does the whole thing work? We have basically a strategy that is not the only strategy. With these kind of tools, we figure that there is lots of ways to approach it. And for example, yeah, the Wonder Dynamics way is one. Then now we do something else. But what we bet on and we decide to do is that we let you talk to an agent, then the agent picks up some motion from somewhere, a bunch of motions really, they get sequenced, and you get the result. So this means that we make some bets, which are defining our strategy, and what we bet on is high quality of the motion, just because there is plenty of offerings out there that say, okay, you can capture your own motion, and this is something which is very attractive for investors because it's scalable. So you just give it to the users, they're going to do the work themselves. But if you have seen professional animators, you might have noticed that they are not maybe the most athletic, the most they're not everybody is a martial arts artist or a character or a dancer. So high quality motion is naturally coming from professional performers, which we are betting on. Then touch up the animation by an actual animator, which is a lot of our human element. We don't want to be AI that gets the job done and serves the common folk all that they need. We want to enable creative people to do stuff, so we do have a human that touches up everything. Then we use Houdini in the backend, which for us is first something that there is a bit of a head start because we have done so much of this until now, and second, so much of the work is already being done, so you can build up on top of it and have good stuff which is much more accessible for a small team to implement rather than building from the ground up, which would sound insane and impossible. Then instead of selling motions piecemeal like we have a lot of the current offerings, we actually give you a subscription to a library which continuously grows. So every day our team is capturing more motions. You get like the list is increasing. So you get kind of the Netflix effect of the FOMO. Like if you unsubscribe, there's going to be hundreds of new motions that next week you're going to miss out on. And then there is these traditional challenges of rummaging through a lot of through deep tables of motion. It's hard to find the stuff that you would need. Like, let's say if you use traditional motion capture, maybe a lot of people have dug into Mixamo or into the I think it was, they are basically open source motion datasets, and they know how hard it is to dig stuff out of them, to then splice it up, retarget, etc. It takes work and effort, rig your characters. So we bet on the AI agent being able to do this stuff for you. So I'm going to talk in a little bit about how this whole thing works. And at the end, if you would rather actually do the stuff yourself, most of the work, we actually give you a library interface or give you an export which gives you all the source stuff. Maybe you just found something that you like, but the retarget and the mixing of the motions doesn't really work for you. You still get all the source data, so you can do it yourself if that's what you would prefer. So this is kind of our strategy. It has pros and cons. So we get good quality and a very lifelike motion. We don't have to pay for training expensive AI models. Like if you see what NVIDIA is doing, for example, on some models which are trying to infer the motion directly, you say these are not very high quality and very expensive. And our inference even is very cheap. So we just ask the language model like what you would do if you talk to ChatGPT. The cons are that it takes extra work to make these motions interact with the environment. So if we have some animation which is picking something from the table, but you want to switch it to a bigger table, it takes extra work for us to make it adapt to be able to understand that it picked up from one level of a table and it needs to retarget to another one. It's not impossible, but it is going to take some extra work. The scope of motions that we can pull from is limited to what we have in the database. Like if you want your character to do some Aikido and we only have karate, it's not going to have it. But still, we tell you, okay, just give us the request. Next week, we hire a local Aikido champion, record the motions, and you're going to have an Aikido in the database. Or Taekwondo. And then at the end, it's not directable in the very fine detail, so it's not going to be something that is being maybe your lead characters, but also we don't really want it to be. Like we don't want to say this is an alternative to an animator. It's not a fight that I want to fight. It would be kind of a civil war for me, so no. I would rather want to give somebody like either do the work for all of their huge volume of background stuff and the life in their world, and give them a start point for their lead character, then replace the person who's going to do the actual performance. So it's not my goal. We don't want to be there. So let's dive a little bit deeper then. First, what we do is we capture. So we use inertial motion capture because from our extensive tests and from our small team size, we are 6 people in an apartment. This is the best quality with the lowest amount of cleanup that's necessary. We have some witness cameras that we capture every time. So whenever there is something in a database, you see the witness cameras with the 3D. So you have an idea about how the whole thing looked. And if there's something that you need to touch up, you can compare. We have a database inherited from our VFX days. It's, Outdesk guys are here, so it's Shotgun, or what was it called these days? Flow. So this helps us a lot because all of the work that we have done on the VFX to make stuff iterable, we actually can carry over, and this saves a lot of time. And when we publish data in Shotgun Flow, we include. I actually had a screenshot that there was a single screen that I captured, like a rectangle, and on the single screen there was like on the website, on the web app, and on the the DCC app, there was the 3 different names were there. So it's called Shotgun, ShotGrid, and Flow. So I thought, okay. So this was a little bit funny, kind of a life lesson. These things should not be taken lightly. So then, we have rich data which goes into a database. So this is all the capture files, including their exports, the witness cameras. So whenever if we want to go back a little bit and to repolish something, we have not lost any data. Now then we process these raw captures, which is happening in Houdini. And I actually usually hate these presentations that don't have a bunch of visuals in them. So that's kind of how it looks from the point of view of a user. I actually am going to do the risky thing, and I'm going to open up a... Can I open up a live session? Just so we have something in the background. It takes like 3 minutes now because it's our hardware is shit. It's some virtual machine with like 8 gigs of memory, but for early adopters, it's acceptable. Hopefully, this is my interface. I'm going to talk about stuff, and let's say I'm going to say jump, but in a funny way. Okay, it's going to take a couple of minutes, so I can go back to the presentation, but there is going to be hopefully something fun soon. So what we do is that we built a few Houdini tools that make the whole thing much faster to process, because yes, the captures, they're not even visually directly readable. So it looks like it doesn't have really a visual component. Like there is a viewport of the software when you capture them, but we want to rather get into something which has, which looks like, let's say, this in our database. This is straight from our Shotgun Live. So we have the witness cameras. We have a retarget to a puppet, which actually is not a retarget. It's a straight copy of all the joint transforms, just so we don't do anything extra. And that's how we like the thing to look into the database. Initially, it looks only just like this, because these are only our witness cameras. They have a bunch of files that, like, there's nothing interesting to see. But if you look at all the fields, you see that there is a bunch of file paths which contain all of the data that was being captured. And then on the next step, when we are actually publishing it, processing the captures, we load this data and we put it into Houdini to come up with automatically with this result that you just saw with the puppet and the witness cameras on the side. This makes it very visual for people who coming from an animation background, from VFX background, to see immediately what the result is and to say, okay, something is wrong here. Please make an update. Mark where something is wrong, so somebody can go in and polish it up and publish the next version. So, while we tend to automate and remove everything which is not human decision out of the loop. So everything which can be done just by guessing by where the files are, etc., database contents is being decided, and we tend to focus on what the human has to decide. So in our case, we motion capture without fingers right now, because results that we have had are not the best. So we let people actually hand key the finger poses using some blend shape style animation. Houdini is really great at that. We just built some tools, let people define poses, then they can blend between these poses. You insert different poses or some other stuff that you can like retime, let's say, only one blend shape. It's quite flexible like this, Nodo, etc. I used to think that animators are a little bit more conservative. I have met a couple lately that give me some hope, so there is hope always. We also split up the performance into a few regions, just because it's not practical to capture short performances. Let's say if we look here in this chess example, you can see that we have 2-3 minutes, something like this capture, because in a day's work, it's not very practical to capture 3-second motions, and it's not something which works for the performer either. So what we do is that we give them a scenario, and then they act, and afterwards we splice this up into a bunch of separate motions, and this way we can have a granularity which is defined after the fact, and we can play with our granularity to see if you want to have like a more or less granular. Sometimes we have both, like we have big performances and short performances, just because they're useful in different scenarios. And we can have a more apt description for each of these pieces. Like, if you want to do detailed choreography, shorter performances work better. If you want to have an effortless big injection of life, then big performances work better. Like, if you just say, like, spend some time in a hair salon, so it's going to pick up these big performances. You don't need to say, okay, trim on the left, trim on the right. You just want, the life to come through. But if you want to do something the other way around, like if you want to say, look left, look right, and then cross the street, then you need the shorter clips. So we kind of end up doing both. Okay, we retouch them when necessary, just to do some cleanup. Sometimes it's necessary, not too often. Sometimes we just scrap the takes and we recapture if there's too much to do, because we aim at about 600 motions a week, between 300 and 600 motions, which means that we have to be quick. So then what happens at the backend? Now here I need to be careful because I tend to get carried away and I don't get the timer, which is challenging. So the backend is fun, and I'm not the developer on the project. I'm more of a product manager, but I try to know as much as possible about what's going on, and sometimes I influence it because I have a computer science background, so I can't help. There is the heart of the backend is our kind of traffic controller. So there is a system which is receiving the user requests and then doing all of the tasks that need to be done. So this is the Houdini sequencer, calling the agent, giving stuff back to the user. There is something which is just managing this whole thing. It's now written in Python. We are looking at transferring to Go eventually when the scalability becomes an issue. But Python was very accessible for us because everybody from the team is coming from visual effects background. We know Python. That's what we do. We use RabbitMQ to do the queues. We wanted to maybe do something which is like a deadline or Houdini's queuing system, but RabbitMQ was more convenient for the developers because they don't have as much Houdini experience. So the line has to be drawn somewhere, and that's where it was drawn at this point. Our database is Postgres, which contains everything except the stuff that goes into Shotgun. So we figured out at some point that, like in the beginning, I was naive. I was thinking, oh, okay, why should we have like 3 databases? This is a waste. We should just have one database and put everything in there. But it turns out that this is actually stopping you from having each of these subsystems be owned by its author. So this means that people have to be stepping on each other's toes way too much. And when you have separate components that have a fixed interface in between them, things are much more peaceful, let's say, even if there is some rework. So this backend database is a Postgres, stores a bunch of stuff about the agent, about the users, about the requests, about the stuff that gets returned, all of this kind of stuff. Maybe here we already have something. Huh? So there you go. What did I say? I said verbose mode is for people who enjoy JSON, reading JSON. Maybe not everybody's cup of tea. So I said jump, but in a funny way, which is very nondescript. A lot of times, if you don't know what you want, but you just want like an emotion, you put in stuff there and you get some stuff. So you see she's jumping, she's doing things. This is like cheering. You could get the descriptions of these motions, but I just wanted to have something there. And I can say, okay, that's cool. But it looks exhausting. Can you rest at the end? Okay. And now I'm having a conversation, so it's not a prompt which pulls something from database. The agent has access to what you have talked about before, to what the current description of the animation is. It's this one, big JSON. And when you talk to it, he's gonna adapt the description of this choreography to what you are talking about, which is some of the magic of the agent. And so the Houdini is running at the backend. So this is, like I mentioned, something which makes us very or faster to deploy features with a very small team. Like I said, so our team size is 6. We have 3 people on the animation department who capture and animate. We have 2 developers who are back-end machine learning, and we have 1 person who is the engine, so writing the Houdini stuff, and myself, who is like just the annoying guy. So the way that we approached this was to write a fast API wrapper around Houdini, and this is a very friendly, basic way to create an API around an application. Because what we need to do is to have some web service that gives some parameters to Houdini, and then it executes and gives us a result. So fast API lets you create the so-called endpoints. So these are commands that you can call from outside Houdini, basically, and we can bind them to some stuff which happens inside Houdini, and Houdini is going to be able to execute based on these external commands. UVcorn is a web server that makes Houdini be able to receive these commands and execute and give results back. We're thinking about making this open source because it's so cool. So we are using it in one kind of way, but you can do anything with this server. So if you have like I'm kind of daydreaming about all of the procedural asset builders that we have made. Like we had one which is very cool for grass, and putting this on somewhere as a web server. So publish the parameters, you can dial something in and you can get results. This would be awesome. And with the agent actually is even better because you don't need to publish the parameters. You don't need to even give people, like let's say a sophisticated procedural thing has 50 parameters. You just give them the agent and let them talk to the agent, and then you teach the agent how to fill out these parameters. So you say, if I have a parameter which is the height of the grass, you just tell the agent, if the person talks about a grass which is tall, put into this parameter a 1, and if he talks about a grass which is low, put a 0.1, let's say. And the agent is doing the magic of interpreting, through this conversation, what the user is talking about, and fills out all of these dozens maybe of parameters. So this way you can just have a procedural tool set which is interfacing with natural language. And our thing here is something like this, but it's for animation, but it can also be done for other stuff. So I'm just leaving the back door open. If money completely runs out, we need to pivot, that there is other Hail Mary passes that we can throw. So all the tasks that Houdini needs to do, so a bunch of them obviously. Ingest means picking up your character, because we say, okay, give us your character, so we just upload it into the system, convert it to our internal format, etc. And because Houdini can read a bunch of geometry formats, this is welcome, so give us your whatever. Then we auto-rig it. So this is a proprietary code, but it's based on open source research that we have picked up from DNAC, I think. It's quite cool. So you can for basic use cases ignore skeleton. So we're just going to build a skeleton for you. We sequence the motions using KineFX. Super amazing tool set. So you can splice up motions, mask them, and combine them in layers. Very cool. We retarget to your character because when we play with the animation, this is on our skeletons that are that is our work skeleton. So this needs to be eventually at the end of the day retargeted to your character. So sorry, I think I will hit errors. This is happening at the end. It's something cool about this is that we need a couple of things to be able to retarget to a character, and one of these things is the mapping of the joint names. So if your skeleton has one names on the joints and our work skeleton has other names of the joints, traditionally you need to do this map, but we figured, if we ask the language model to do this map for us, it is actually doing the work because the names of the joints make sense, they're just different. So you're calling your left elbow, let's say L_elbow 23, and we are calling our elbow L or left. And language for the language model, this is enough information to be able to make the connection between the two. So you don't need to do it manually. So now we just need the poses to match. Then we have tops, which are doing the sequencing and export work. So this has become a little bit of a Houdinish thing for too much for a general audience. But anyway, there is a batch processing system where you can render stuff out, collect your products, and give it to the user. So for our programming guys to the backend, we just serve them one file that has everything packed inside and everything else happening in Houdini, which is very cool. And you end up with FBXs, etc., that you can use in your pipeline. So the very cool and a little bit esoteric part is the vector database part. So the way this whole finding of animations thing is working is that the language models are able to embed, so to say, is the term, text as a position in some hyperspace, which each dimension is some term. So this makes it so that you can search in a database just like of meanings, just like you do with in space with positions of stuff, and you can find something which is close by meaning, just like you find something which is close by position in space. So, long story short, this is something that lets you find things by meaning just because they are close to something else's meaning. So we label our motions. This is done by a person. We are trying to see if we can make the language model label stuff, because the human is very good at describing the intent of the motion and the emotional content, the function. But it is helping us when we have to describe because the language model, when it searches into this database, they don't see the video of the motion. They are just reading the text. So we have to describe it to him as if you are describing the motion to a blind person, just so they know exactly how the character moves. And this is something which is a little bit tedious for a human to do. So we are testing out language models to also add this layer of description, and we end up with a bunch of layers of description. One of them is kind of the emotion, another one is the function, and then there is the look. But this is still R&D, so we haven't deployed this yet, so it's promising. And then the AI agent is retrieving just like I described. So the agent is not just a language model. That's why I don't say language model when I mean the agent. It's kind of a pipeline of machinery which has the language model as a centerpiece, but we write a bunch of tools, as they're called, to give the language model stuff to use. So it needs to be able to have access to databases like the vector database, to the history of your conversation, to the result from the animation so far, so it can add stuff to it. I think this was a little bit unsuccessful, but I'm going to try another one. So I'm going to say clear, and I'm going to say jump, but before that, warm up a bit. And to build this agent, we are using the OpenAI language model right now, but we don't ask too much from the language model, so we can switch to Mistral or to Llama if we want to. And then LangChain is the framework that our machine learning lead is using to build all of these tools and hook them up together. And like I said, the tools are the cool stuff which lets you do all of these cool small things. Which makes the agent something more than a language model. And we have a front end, just like you just saw. It's a front end made by backenders, and as soon as we have dedicated front end people, things are going to become prettier. But for now, we are focused on function, and the console is great for this function. We hope that people are used to by now to Midjourney, etc. So they will not be very pissed off by this. And our main motivation was to be able to make it very integration friendly, because we want to be able to have this into everybody's pipelines. So this is not the end of your work, like I mentioned earlier. We want to give you tools, and we know that you have a big pipeline, and we want something inside to slot into this pipeline, so it stuff goes in and comes out of it easily. So to do this, we built it on top of a Python client. Everywhere we can build in some Python integration. So Unreal, Blender, Max, Maya, anything has Python running. So when we have Python interface, we're going to be able to integrate. And we have a web app, which is just our console reference integration, just so we have something to show everyone before we have all of these integrations. And it also gives us API access, which is important if we want to approach somebody, say, okay, you guys are from Cascadeur, you have such an awesome tool. Do you want some animation source that could be used as a start point? Here's your API access, and then you can be able to access Cairos from inside your platform. Hopefully, this would help us out on the business end. And then there is a layer which is very often ignored, but super, super important. You need to be able to get subscribers in, charge them, email them with new features, all this kind of stuff. And we are using a platform called Outsetter for this. It's getting connected to our backend database, but the rest of the work is being done by the Outsetter team, which is amazing. So just replicate some of the data from there. So it has information about who is on which plan, and who has, and we give it information back who has used how much credits, this kind of stuff. So pretty cool. Okay, so this is my last slide. Of course, thank you first to Milica and to Milena. This was amazing. To all the volunteers, I'm making some small events in Sofia, and I know even a small casual event is so much work to organize. So these people are doing something great for the community and should be applauded. Thank you. And for all of you guys who want to try it out, if you scan the code or if you open up the link, you can access a 1 month unlimited free trial. And eventually, if you end up liking it, first, please give us feedback, because it's an early, rough version that we have a bunch of things to fix. But our goal is to listen to you and fix the things that you need most. So we end up with something that you guys can buy eventually in a couple of months. So this would be amazing if you guys can give us some feedback. And eventually then, if you get to a place where you want to buy it, this would be our pleasure. Find me anywhere. My phone number is here. Wake me up in the middle of the night, no worries. I have a baby, 9 months old. He's waking me up anyway, so I'm awake. And yeah, thank you.